Okay, 9.4. Our first one is doing a 5
What
number.
happened with 9.3?
That was the snow day.
Oh, what? I didn't know that.
I'll teach it today too.
Okay.
I won't record that one, but I'm going to teach both. So 9.4 we're doing first. It wants the 5 number summary. Those 5 numbers are right here. 2, 3, 4, and 5. This first one is the minimum. 1, 2, 3, 4, 5. Are you okay saying it's 3?
Yeah.
Then this is the quartile 1. So it's 1/4 of the data. This number would be 7? Yeah, let's say 7. Then the median, it's almost to 10. Are you guys saying 9? 9. Okay, what do you think Q3 is? What?
23?
23?
Yeah.
Okay. 23. And the maximum. 25. So we're just reading the box plot. You know why it's called a box plot?
It's a box.
It's a box.
Yeah.
Easy. So smart. Next one, vertical distance. Does anybody think they know how we're going to count the vertical distance? How far do you think this vertical distance will be for that 1 point?
2.
I heard 2. Why 2?
Vertically up and down.
It's up 2. And a 1. 1. 1. 1. 2. 2. 2. 1. 2. 1.
So with a line graph like that, do you always have to do y equals x just right across?
They will. Yeah, they will compare their data to this, and then on the next problem, we'll compare it to a different equation. Yeah. But for now, this is the line that we're comparing it to. What is the sum of all the numbers? 2 plus 2 plus, oh, that's not 2. 2 plus 1 plus 1 plus 1 plus 1. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is that okay?
Yep.
You add up to 16. What would I do to find the average? What would I have to do with the 16?
Divided by
How many numbers are there? 11 numbers. 16 divided by 11. 1.45. I'm around the third number to a 5. On the computer, for your answer, try and put at least 3 decimal places. It's been weird with decimals lately. I will double check, so if you accidentally rounded it, I'll give you full credit. I marked it wrong. Do you think the line drawn fits the data points? No? Why would you say no? Oh, it's okay. Because they're all scattered. No. Okay, that's a good explanation. Anybody else have an explanation, Caitlin?
Oh, well, I put not a single dot on the line.
Okay. What's another reason?
It's like, it's supposed to go where most of the dots are, so it's not on any of them, so it's not.
Okay, what were you gonna say?
I was gonna say the average doesn't match the equation.
The average doesn't match the equation up above. Okay. I'm gonna write one more thing. Those were all really good answers, right? When I look at the top, there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 dots up here. Or 13 distances. 1, 2, 3, and there's only 3 here. How could I describe that? Not balanced, not equal.
Not even.
Ooh, I like that one. Not even. Right. It's not a bad line, it's just not the best. Turn the page. For this one, it says the weekly sales of an album have increased since it was first sold at a music store 6 weeks ago. The linear regression equation describing the change is y equals 2x plus 14, where x represents the numbers of albums sold per week. Complete the table to determine the residuals for the number of albums sold per week, then create a residual graph. So this is the actual number sold. They built this equation because they want to attempt to predict how much they will sell further on in the future. Now, for the first one, when I plug in a 0 to their estimate, this would be 14. When I plug a 1 in, that would equal 16. When I plug a 2 in, that would equal 18. What's my pattern doing so that I don't plus 2, I can just fill it in. I don't have to do plugging in the whole time.
+2.
Yep. Because 2x. 2x is my slope. It's adding 2 each time. I start at 14.
Oh,
I
yeah,
add
you're
2.
right.
Now residual. I'm going to find how far the original number is from the predicted. What is 13 minus 14? -1. What is 16 minus 16?
2.
0. What is 17 minus 18? 18 minus 20.
2.
-2. 21 minus 22.
2.
-1. 23 minus 24. All right, now, they won't always be negative. It just happened on this one. Sometimes it will be a positive. When I graph the residual points, 0 will be at -1. 1 will be at 0. 2 is at -1. 3 is at -2. 4 is at -1. 5 is at -1. Then I graph them. 2 is down 1, down 2, down 1. Was this a good linear regression? Were these pretty close together? Yeah. Yes, that was good. Is there a residual pattern? Do you see numbers repeating, repetition anywhere? What's the pattern?
There's a lot of negative ones.
A lot of negative ones. Do they repeat in a specific way? What's your
It's like going from a negative one, and then it's like adding to, and then going back to negative one, and then adding to, or subtracting.
negative 1, 0?
Mr. Anderson?
Yeah.
Talking about the graph or the numbers?
The numbers. Do you see a pattern with the numbers? You can also use the graph. Do you see a pattern? Is it going?
Yes. I can see it in the graph.
Okay. So notice, let's try this one. If it follows the pattern, up 1, down 1, down 1, up 1, it should repeat. Does it keep repeating?
No.
It does not repeat. So there's no pattern. You want to look for repetition. So this last dot, this one, that's what messes up my pattern. If it went up to 5, can you see how it would repeat?
Yeah.
That does not repeat. It's really close though. Last question. You need to use your calculator to enter the data from the table. When you do this, this is what you will get in your window. Are you okay with me not typing it in?
Yes.
Yes? Yay, perfect. Okay. Linear regression. I'm going to put that y equals 1.22451x plus 6.61484. If you want to round, you may round it at the third decimal place. I'm just going to put the whole decimal, make it easy. I pulled those numbers from M for my slope and B for my y-intercept. Correlation, coefficient. R equals 0.748. That's it.